problem solving for today uses angle of elevation. Hello genius, here we are again for another math problem. A tree stands on a horizontal plane. Find the height of the tree if the angle of elevation of its top changes from 20 degrees to 40 degrees when the observer moves 75 feet to its base. Now, if you will make the rough sketch of this one, there is a tree here stands. There is the tree and there is the observer here. So, it said the angle of elevation changes from 20 degrees, from the top 20 degrees to 40 degrees. Now, for example, you will see this one. This is at 40 degrees. And this is at 20 degrees. And the observer moves 75 feet. So from here, the observer originally here moves to this point. So from here to here, it is 75 feet. Now, what we're looking for here is the height of the tree. So we will designate this one as A. The other one, this point is, for example, B. And this one here is C. And this point here is D. So here, if this one until this one is 75 feet, so this one, this is EBD, triangle EBD is an isosceles triangle. This one from 20 degrees is moved to 40 degrees. So, means this angle here is equal to 140 degrees. Because the total of this angle is 180 degrees. Now, we have AB and BD, which is equal to 75. AB, distance from A to B is 75, and this one, since this is an isosceles triangle, BD, which is equal to 75 foot. Now, in triangle BCD, B, C, D. So if we will designate this one from B to D as X, therefore we can find the height of the tree from the triangle BCD, which is equal to the height, which is equal to, because this is the sine of 40 degrees is equal to the height over the hypotenuse, which is the x. Therefore, height is equal to x sine of 40 degrees. Now, since x is equal to 75 feet, this is BD, which is we designate this as x. So we can substitute the value of x The height of the tree therefore is equal to x sine of 40 degrees so x is equal to 75 sine of 40 degrees. Therefore, the height of the tree, which is equal to 48.21 feet. Another question, a guy wire of length 108 feet runs from the top of the antenna to the ground. If the angle of elevation of the top of the antenna sighting along the guy wire is 42.3 degrees, what is the height of the antenna? Now, putting the rough sketch, if this is the angle of elevation of the antenna going here to the guy wire, is 42.3 degrees. So this is the guy wire. So this is the height of the antenna. This is the height. No. We'll designate this one as A, B, and C. So from here, because we have the given length of the guy wire, which is equal to 108 feet. So this is the length from here to here, which is the length, which is equal to 108 feet. Runs from the top of the antenna to the ground. Now, if the angle of elevation is 42.3 degrees from the top, what is the height of the antenna? This is the one from here to here. So, this is an easy question. Just we will use the sine function. Sine of this angle, which is 42.3 degrees, is equal to the opposite, which is the height, over the hypotenuse, which is the length, 108 feet. Therefore, cross multiplying, height therefore is equal to 108 times sine of 42.3 degrees. Therefore, this, after simplifying, the height therefore is equal to 72.71 feet. So, this is the one we're looking for. 72.71 feet. These questions were given last November 2016 board exams. Now our third question. An engineer is hired to design a bridge to carry traffic across the river. Her first problem is to determine the distance from point A to point B. To do so, she starts at point A and measures a distance 250 meters in a direction at right angles to the segment AB. At point C, she uses her transit to find the angle of ACB, which measures 49 degrees 50 minutes. How long should the bridge be? So, in here, if you're having the rough sketch of the bridge, and we have this one. Now, from the segment A to B, this is a straight actually. My hand is. And so we have, start from point A. It measures a distance 250 in a direction at right angles to the segment AB. So at right angles, so this is, will become right angles here. So from here to here is 250 meter. Let's see this one as C. So 250 meter from distance A to C, which is equal to 250 meter. So if we have this one and this one, so it will, you will be having a right triangle at point C. Now it says here that she uses her transit to find the angle ACB. That means this angle, which measures 49 degrees 50. So 49 degrees 50, the theta, the angle. So how long should the bridge be? So we are looking for this length from A to B. This is the one we're looking, the length of the bridge. Now just we can use this tangent function. Tangent of 49 degrees 50 minutes, this is tangent here, is equal to the length, this is the opposite of the angle over the adjacent, which is equal to 250 m. Therefore, cross multiplying this one, L therefore is equal to 296.184 meter. This is the length of the bridge.